In this video the following concepts are studied. Introducing the three main kinematic graphs. Draw a graph, in constant velocity mode. Draw a velocity time graph. Draw an acceleration time graph, etc. Graph in kinematics. Earlier we talked about velocity and graph separately. But now we want to show the relationship between the two, that is, if we have a graph, how can we find the velocity or the moving object place and vice versa? We are currently talking about moving at a constant velocity. In kinematics, three main types of graph are examined. 1. Position time graph. This graph shows the location of a moving object at different times. 2. Velocity time graph. This graph shows the velocity of a moving object at different times. 3. Acceleration time graph. This graph shows the acceleration of a moving object at different times. We examined the place time graph in the previous sections. We will examine the acceleration time graph after introducing acceleration.
Note, if an object moves at a constant velocity, its graph is a straight line. To draw a line, it is enough to draw 2 points of that line, and then cross a line through those 2 points. Example 1. A car moves at a velocity of 2 meters per second on a straight line in the direction of the coordinate axis. Draw a position time graph in the following case. A. When the person was passing 3 meters before the origin of the coordinates, we turned on the stopwatch. Answer to A. Because the velocity of the car is 2 meters per second, it means that it moves 2 meters at 1 second. At moment 0, the moving object is at this point. 1 second later, that is, at this moment, it moves 2 meters in the direction of the coordinate axis. That is, it reaches this point. So its graph is as follows. B. When the person was passing the coordinate origin, we turned on the stopwatch. Answer to B. At moment 0, the moving object is at this point. 1 second later, that is, at this moment, it moves 2 meters in the direction of the coordinate axis. So it reaches this point. So its graph is as follows. C. When the person was passing 3 meters after the origin of the coordinates, we turned on the stopwatch. Answer to C. At moment 0, the moving object is at this point. One second later, that is, at this moment, it moves 2 meters in the direction of the coordinate axis. So it reaches this point. So its graph is as follows.
Now, let's look at the three modes together in one shape. In case A, when we turned on the stopwatch, the car was in this place. The graph looks like this when the car is moving. In case B, when we turned on the stopwatch, the car was in this place. The graph looks like this when the car is moving. In case C, when we turned on the stopwatch, the car was in this place. The graph looks like this when the car is moving. You may be wondering why all three graphs are parallel. The reason is that we assumed the car velocity to be the same in all three cases. In fact, the slope of all three graphs is the same.
In the previous example, suppose the car moves at the same speed, in the opposite direction of the location axis. Draw its graph in all three modes. The details are quite similar to the previous example. You should reach these graphs at the end. Do it yourself as an exercise. In the previous examples we looked at the position time graph. Now we want to look at the velocity time and acceleration time graph. Tip 1. The unit of distance and displacement is meters. The unit of velocity and velocity is meters per second. The unit of acceleration is meter per second square. Tip 2. We want to examine the concept of acceleration. Acceleration is velocity changes in unit of time. For example, if acceleration is 5 meters per second square, it means that it increases by 5 meters per second per second. In other words, in 1 second, 5 meter per second is added to the velocity of the moving object. Suppose the object velocity is 12 meters per second. In this example, 1 second later, its velocity becomes 17 meters per second, and 1 second later, its velocity becomes 22 meters per second. Tip 3. Velocity time graph of moving object which moves on a straight line at a constant acceleration, is a straight line. 3 modes may occur. Case 1. If the velocity increases, the graph looks like this. In this case, the acceleration is positive. Case 2. If the velocity remains constant, the graph is as follows. In this case, the acceleration is 0. Case 3. If the velocity decreases, the graph looks like this. In this case, the acceleration is negative. Consider the following example. We want to talk about the concepts here. So we do not use any formula. We will introduce the formulas later and use them.
Example 3. A car is stationary at first, then at an acceleration of 2 meters per second square, it moves for 3 seconds. It then moves at a constant velocity for 4 seconds. Then it stops at an acceleration of 3 meters per second square. Draw velocity time and acceleration time graph. First step. The car is stationary at first, so its velocity is 0. Because it moves at an acceleration of 2 meters per second square. So 1 second later its velocity becomes 2 meters per second. And 1 second later its velocity becomes 4 meters per second. 1 second later, its velocity becomes 6 meters per second. Second step. The car moves at the constant velocity of 6 meters per second for 4 seconds. Third step. The car slows down with an acceleration of 3 meters per second square, so after 1 second its velocity reaches 3 meters per second, and after 1 second its velocity becomes 0 and the car stops. Now we consider the whole movement at the same time to see the steps better.
Now we draw the acceleration time graph. First step. The acceleration is 2 meters per second square, and for 3 seconds it moves at the same acceleration, that is, this line. In fact, because acceleration is constant, its graph is a straight horizontal line. Second step. The car velocity is constant, so the acceleration is 0. This step took 4 seconds. This line. Third step. The velocity decreases, so the acceleration is negative, and is equal to -3 meters per second square. This step also takes 2 seconds.